The main objective of the practice was to evaluate the microstructural changes that the welded steel experienced through the process of an electric arc welding through the different zones that make up the welding cord. Also was to remember the previous practice that we saw in materials behaviors. The materials used for this practice was steel plates, electrodes for welding, silicon carbide, cloths and microcloths, colloidal aluminum, and phenolic resin or bakelite. The equipment that the team used to develop this practice was milling machine, polish machine, Vickers durometer, metallographic microscope, mounting press for metallographic specimens, abrasive disc, welding machine, and of course, safety equipment.
For our experimental procedure, first we made a weld through the two plates to connect them and analyze them. Then we made a cut through the weld and the plates with two samples, one of the weld and the other one of only the plate to compare them. Then we made our metallographic preparation in bakelite. Then we use the Vickers test to analyze the hardness. We made different tests in each part of the sample, going from the weld through the part of the plate to compare how the weld hardness was through the plates. And we made also a Vickers test only of the plates, and we analyzed the grain size in the final step.
As a result for this practice, we expected that the hardness of the steel with the welding increased due to the fact that when the process of welding occurs, the steel is melted and it solidifies again, changing its properties, reducing the size of its grain, and this increasing the hardness. For the steel with welding, we counted 24 grains, and without welding, we counted 21 grains. As we can see in the calculations, the size of the grain did not change as much as we hoped. In the Vickers hardness test for the steel with welding, we did 5 measurements, and for the one without the welding, we did 2 measurements. For each piece, we got the average hardness. For the piece with the welding, we got 199.6 Vickers hardness, and for the one without the welding, we got 129.5 Vickers hardness. This means that the welding process did increase the hardness of our piece.
As previously said in class and by my teammate, the microstructural change occurs because of the heat resultant of the process of welding two metals together. When welding, you have to increase the temperature to make both metals join together. This increase in temperature has an effect similar to heat treatments because the rise of temperature, but it differentiates on how the hardness is affected. In a heat treatment, the whole material hardness changes, but in this case, in welding process, as you get closer to the fusion zone, the hardness increases and it decreases to the normal hardness of the material as you move away from the fusion zone.
Welding in steel have advantage and disadvantage. You can have a bigger area, sometimes the union has better properties, it's cheap, and on the other side, it is manually applied, dangerous energy used, and maybe some quality defects in the parts. The grain size is one of the structural changes that we are expecting, because if we have bigger grain size, the property changes. The heat affects the area next to the weld applied, so in this section the hardness of the material is reduced and other properties. The arc welding with coated electrode works, but in the USA means sheet metal arc welding. We need an intense heat is produced by an electric arc. This arc generates when the electrode separates from the piece, and this arc produces a high temperature, and this weld the material it's applied. The electrode transports the energy and supply the energy to the electrode weld, and the two parts join together.
My conclusion is that the change in hardness due of the welding, we must consider it for designing anything, because it can make our material or the shape we form welding inappropriate for our requirements.
In conclusion, we learn how to make a metallographic preparation, and we can learn how the weld will affect the plates through the heat of the weld. When we were welding, we can see that it was different hardness than in the plate.
As a conclusion, I found really interesting how what we learned in class was applied in the daily life with this laboratory practice. We all know that the process of welding has been in the manufacturing processes since a long time ago, and now we can see why it's functioning really well.
In this practice, we remember how to make a photographic part and check his micro hardness and the grains in his structure. Also, we checked the change in the weld piece, so we can see that it changed. His microstructure is less hard than the part of the metal. So the weld changed the structure of the metal, but instead it has an advantage, like you have a bigger area with the weld.
In this practice we apply the themes that we are learning in class, also the previous knowledge from material behaviors. For me the practice was really interesting because I have never do anything of the procedures before, also because I can understand how a metal becomes harder when it receives heat treatment or just heat. As we saw in the results, the microstructure is not constant, but is because the heat wasn't applied in a constant way.